You've probably spent hours tweaking your WordPress site and compressing images, only to run a speed test and watch your mobile core web vitals tank. The immediate reaction is usually to throw more premium caching plugins at the problem, hoping to force the site to load faster. But stacking these tools often leads to conflicting configurations that don't actually solve the underlying delay. The debate over which plugin has the better settings ignores the more important factor: which architectural layer is actually creating the bottleneck. Right now, users have two clear paths: optimize your existing server or bypass that server completely. Passing Google's core web vitals requires understanding the physical limits of where your code is processed. Traditional caching tools, like WP Rocket, are built primarily for server-side optimization. Static edge solutions, like Nimbica, are built for server-side evasion. These aren't rival tools you have to choose between.
Welcome to Nimbica.
They operate on entirely different layers of how a web page is delivered to a visitor. To fix your speed issues, we need to map the mechanical difference between these two layers. Once you understand the architecture, breaking through that performance ceiling becomes a predictable process. Think about how a standard WordPress request works. A user clicks a link, and their browser sends a request across the country to your origin server. That server has to wake up, execute a stack of PHP scripts, and query your database just to figure out what the page looks like. A caching plugin jumps into this process by pre-building the page and saving it as a flat HTML file on your server. That drastically reduces your database load, meaning the server can hand over the file much faster. But there is a hard ceiling here. You are still entirely reliant on the physical location and capacity of that single origin server. If your server is sitting in a data center in New York, a user trying to load your site in Tokyo is going to experience a delay. And if you get a sudden spike in traffic, that single server can get overwhelmed, meaning even those pre-built, cached files are slow to send. On top of that, heavy visual themes and page builders put a massive load on PHP. No matter how aggressively you cache, the underlying engine has to work hard. Caching takes pressure off the server, but it leaves you with a single point of failure that struggles to guarantee perfect mobile speeds around the world. This is where the static edge approach comes in. Instead of keeping pre-built HTML on your server, you move it away from the origin. Those static copies are pushed out to a massive global network of edge nodes. They intercept user requests locally before they ever reach your WordPress installation. You don't give up your WordPress backend. You still write posts exactly like you always have. Connecting the two is straightforward. If you look at this Nimbica dashboard interface, you simply generate and copy an API key. Then you download a standard WordPress plugin and paste that key to sync the site. Looking at the Nimbica Connect plugin inside the WordPress admin panel, you can see the edge is also handling complex processing, like generating WebP and AWIF images, completely offloading that work. Pushing public traffic to the edge protects your server from spikes, bypassing traditional PHP bottlenecks. Let's look at the actual performance data when you route traffic this way. On this standard mobile Lighthouse report, you get a 97 performance score and a 1.9 second first contentful paint. With no PHP wait time, interactivity is instant. Total blocking time drops to just 20 milliseconds. This scales up cleanly to desktop environments. On this desktop Lighthouse report, the site pulls a perfect 100 performance score. The total blocking time hits an absolute 0, alongside 0 cumulative layout shift. Achieving an A grade or a perfect score is a predictable result. As this GT Metrics report shows, removing server latency directly yields a 99% performance grade and a 31 millisecond total blocking time. There is a specific caveat here. Pure static edge delivery needs careful routing if your site has dynamic, real-time elements, like logged-in user profiles or active shopping carts. For complex WordPress sites, the most effective approach is a hybrid stack. You set up a simple decision tree for your traffic. When a request comes in, the system asks, "Is this the public front end?" All standard public visitors are routed directly to the static edge nodes for maximum speed. But logged-in users and admins are routed back to the PHP origin server, where your traditional caching tools ensure the backend stays responsive. Running both systems concurrently gives you the best results for both public traffic and private sessions. If you are a developer managing complex internal queries and tuning direct database response times, traditional caching plugins remain your primary toolkit. But if your directive is strictly to pass Google's core web vitals for SEO, and you want to do it without rebuilding the entire site, you deploy a static edge. Stacking 10 different optimization plugins will never bypass the physical limitations of your server's hardware. True site speed requires recognizing whether you need to tune up your engine or switch to a system that removes the engine from the equation. Transitioning your site to edge-based delivery is now as straightforward as configuring a standard WordPress plugin. Identify the specific bottleneck slowing your site down and apply the architecture that actually addresses it.